I am Ludovica Rosato, and I am a member of the Advanced Design Unit and a PhD student. I'm so pleased to be with you today and to have the chance to introduce our speaker, Jakub Kamecki. He's the technology evangelist of TG0, and his speech is about creating interactive 3D shapes and surface with touch sensing.
Hello everyone, it's Jakub with TG0 here. Welcome to my presentation. So today I'll be speaking to you about creating an interactive 3D shaped touch interface essentially. So this is what TG0 does. We bring touch back. My name is Jakub. I'm a technology evangelist here in TG0. TG0 is a company that has been founded in 2015. Currently the headcount is about 25 people. We have 14 patents for our invention, and let me walk you through it, what we do. So as you've noticed, there's a lot of options in terms of human-machine interfaces. We have voice, we have computer vision, we have touch screens, and obviously the one that is more primal, more natural is touch, and this is where we specialize. All of these interfaces have their benefits, have their downsides. It's really all about context, privacy, what we are trying to achieve in a given scenario. Especially touchscreens have become very prevalent in recent years, and they are an interesting kind of example in terms of human-machine interaction, because they focus your attention on the touch screen itself. We want to take a bit of a different approach, and we want to kind of bring back the sense of touch as a way with interacting with machines, with computers, triggering various functions. And this is what we do. So we create memorable controls every customer can love. So we focus on bringing that intimate and private aspect to interaction. We create 3D shapes, 3D patterns, 3D interactions through touch. So this is an example of what we do. We can detect touch, gesture, pressure, movement, and deformation through using a smart polymer approach. So really any surface, any interaction, and the big advantages of our approach is that we create 3D shapes. There are other various companies that operate in this space. Their limitation is that they tend to be quite flat and uninteresting. With us, you get really this full freedom of design of the shape, of the interaction, and you can really create beautiful interfaces that offer the user, the customer, an exciting way to interact with technology. So here's an example of what I'm talking about. A beautifully shaped, 3D shaped interface that kind of invites you to interact with it. And what we are kind of proposing is for researchers, designers to really think about the form and what kind of function it enables. So this prototype is a window controller. It's just an example we built for one of our customers, and it's also one of the simplest, but also one that is the most fun to operate. So as you can see, you have this kind of protrusion that can be fully deformed, and really the user can interact with it, and it kind of invites them into the interaction. And this is what we do. We want to build shapes, build interfaces that give you this sense of control, of intimacy, of privacy, and invite you to play with them. The idea is that through shape we can educate the customer, and the time to find the function is lessened, the distraction is lessened, it's a more pleasurable and fulfilling experience for the customer. So our technology is also able to be used as a sensor in of itself, more of a IoT sensor, not necessarily a human-machine interface, but rather something that a user can or it can track a user unconsciously. So you don't operate anything, the material just tracks your performance, tracks your movement, weight distribution, etc. So there are two kind of use cases of our approach. One, the human-machine interface in the most traditional sense, 3D shape interfaces, and then you have this kind of IoT use case where we track the behavior of the user seamlessly. A big advantage of our technology is not only the full freedom of design, but also the intelligent use of the core materials. So we don't add anything necessarily, we don't use in-mold electronics, we just use the polymer itself. So in an automotive sector, in a gaming, PC peripheral sector, accessibility, we would use the polymer that is already there. So we reduce cost, we reduce complexity, and offer designers full freedom of design. Looking at the technology stack, just for you to kind of understand how this works on the back end, from the interaction we go to the hardware, and our hardware is fairly simple. So it's mostly technology that is based on software. The non-conductive A side and the conductive B side, that's something that is purely off the shelf. We use non-conductive polymers, fibers, finishes, so it's really up to you what kind of a finish you want to achieve. Then we have the conductive B side. The conductive B side is part of our offering. We've patented a way how to structure the B side material in such a way as to detect various interactions that I've talked about, and then we use off-the-shelf MCUs, off-the-shelf cap sensors that we infuse or we use to deploy our signal processing and AI machine learning algorithms. Through that data, so when a user interacts with this with our material, that data is being captured by the TG0 API, and then we can detect all of the good things that you see on the right, like deformation sensing, touch sensing, pressure mapping, seat occupation, weight measurement, and various others. It really depends on the use case. It's not an off-the-shelf technology. All aspects of this assembly, all aspects of this architecture are up for discussion and up for modification to your specifications. Another huge benefit of this kind of custom approach is that we can very quickly prove that an interaction works. So because we don't use any in-mold electronics, a lot of our interfaces can be potentially 3D printed. It's really about what are your priorities, what would you like to build, what kind of interaction method you want to enable, and with that we enable the research community, the design community to really play with the idea of shape, of function, and really kind of incorporate it into your products and into your research. One thing to mention, because we don't use any in-mold electronics, we don't use wire, mesh, flex or whatever, we remove complexity, we reduce the need for rare earth metals, we lower energy consumption, less waste. So, and as the understanding of polymers, biodegradable polymers, etc. Advances, we can easily innovate and push our R&D to incorporate those materials into our sensing. So because we are primarily software based, we can easily adjust to various materials. So summing up, tangible interfaces for any function, 3D shape, 3D patterns, and really we want to invite you to build new interfaces, new shapes, new functions that are exciting for the end user. Any questions, feel free to ask away. Thank you.
Thank you, Jakub, for your presentation. Hi, Jakub.
Hi, hello.
Hi. It's really interesting to see new and breakthrough way of product interaction. So thank you very much, Jakub, for your presentation. Now I'd like to open the floor to discussion, and waiting for the audience, I would like to ask you a question, Jakub, first. TG0 technology enables innovative and meaningful way of product interaction with the high customization possibility for designers. In terms of accessibility, this is a huge opportunity. Have you ever developed custom interaction to improve accessibility for a product in a design for all or universal design perspective?
It's an awesome question, and personally, I'm very passionate about this use case. Our business model is like we are being commissioned by our partners, by our customers to develop these use case. So unfortunately, not yet. We haven't been commissioned to do accessibility. We've done some initial case studies and viability studies with some foundations in this area. So one of the issues that service teams working with, let's say, disabled gamers are facing is that the mechanical switches, the mechanical joysticks available on the market now have a preset strength, and various people, various gamers with different disabilities have different force activation needs. So for the service teams, it's really difficult to kind of tune or find the switch or the joystick or the interface that meets the force activation requirements for a given customer. With our technology, everything can be tuned in software. So the sensitivity, the resolution, the response rate, the shape, and because it can be 3D printed, we can customize our device for a given customer. So there's a lot of benefits and kind of applicability for accessibility. We just didn't have the right partnership or the right customer to really take it forward.
Thank you, Jakub, for your answer. Thank you very much. So maybe we have some questions from the audience. Andrea?
Thank you. Sorry. Welcome, Jakub. I bring you some questions from our audience and our research unit. First question. At the end of your presentation, you talk about the sustainability of your technology as it can reduce energy, material consumption, e-wastes as well. You mentioned the possibility of using biopolymers in your product. Have you tasted yet these opportunities or just future plans?
It's mostly kind of blue sky future plans. It is an area of active R&D for us. Currently, to my knowledge, there is no kind of biodegradable polymers that are kind of at the TRL level that is ready for kind of mass consumption. So it's just a future thought. But given how our technology is structured or architected, it's all about the software. The software is the kind of magic sauce. The thresholding, the baselining, the signal processing, it's really all in the software. So as soon as these polymers come online or available, we can quite easily take our IP and adapt it. So why we are here, why we are taking part in this symposium is that we are very much looking forward to get connected with the academic community And if you guys have polymers that you want to work with, want to explore applicability of our technology, let's have a conversation.
And you talk about new possible relations with the surfaces, forms, and functions, and you know that among designers, when we use this precise sequence of words, a hard question is coming. And in my opinion, these new opportunities really question the epistemic dimension of the designers of the systems. And how to teach designers to explore these new interactive spaces?
So I'm not sure I'm getting the question. Like, is it a question about our business model? What's the next step, or
how we teach to designers to interact with new possibilities about the relation of forms, surfaces you habilitate?
Okay, so perhaps this is a question for my colleague. So with me, there's Francesca Perona. She's the Chief Innovation Officer. And
Hi there,
yeah, go ahead.
Hi, nice to meet you all. Yeah, I think it's a great question, actually. I think someone before, when we're talking about performance experiencing, there are different kind of thresholds that people are used to in terms of interactions. So some designers really get the opportunity to work in a different way with technology, and other designers need to be briefed a bit better, I guess. I think there are two elements in here. One is really understanding what are the, let's say, user experience possibilities with our technology. And the other aspect is purely the mechanical design and the application of our technology to those specific shapes that the designers need to work with. So when we work with client, we kind of work on both elements. So we do work together on redefining the user experiencing, streamlining it, and making really interactions more natural. When we look at automotive, for example, there's a lot of focus on being able to create devices that don't need to be operated through seeing a screen. So you just reach for the device and you're able to interact with it. So a lot of the studies that we do are actually kind of blindfolded designing and testing of our interfaces in-house and with clients and with external kind of testers. So a lot of that is actually user studies. So the designer kind of get attuned based on the feedback that we get from the customers and from the general public too. Hope that answers the question.
Thank you, Francesca. Now, if we don't have other questions, I thank you, Jakub, for your presentation, and I thank also Francesca for your participation.
Thank you.
Thank you.
Now, I leave the stage to Alberto Calleo.